They will cover Chapter 9, Section 1. Again, I will not be able to do all 12 examples. I'll probably do the first 6 with you, and then I'll finish up and make a second video of the last 6. Now, you should have covered linear system of equations in Algebra 1. When we're solving a system of equations, what we're looking to find is the ordered pair if you were to graph the two lines where they cross. So for example, if you were to take and let's say you have your coordinate plane here and you graph two lines, the solution to this system would be whatever ordered pair this is where the two lines cross. So when you have a linear system, you can either end up with one solution, then you can also have, let's say the two lines are parallel. Remember, parallel lines never cross. This would be the example where there would be no solution. And then you also will have the scenario where, let's say you solve and you rearrange your equations and you find out that they both simplify to the exact same equation. And that's when the line would be graphed on top of the other one. And that would be an example of infinitely many solutions. What we're going to mostly experience here is probably the no solution and the one solution when it's linear. Now, after we do the linear examples, we're also going to see some nonlinear examples of systems. And that could be, for example, a parabola and a line. This time, it would hit my parabola in two spots. So I would have two ordered pairs as the solution. Now, you could also have a parabola and you could draw in the line. And let's say the line is below the parabola. This would be an example of no solution. You can also have, for the nonlinear systems, you could have a circle and an ellipse. So for example, we could have a circle that's graphed here. And then you could have an ellipse that's on top of it. And then notice this would hit it in 4 different places. So when you have a nonlinear system, there's going to more than likely be more than one solution. Now you could have a nonlinear where you could have a parabola and you could have a line, and then the line could hit the parabola at the vertex, and that would be a one solution. So all different scenarios are going to happen when you have nonlinear. When it's linear, it's either one, none, or infinitely many. So in the notes today, we're going to see the examples where we're going to get one ordered pair. Or in the case when we do a nonlinear, it'll be 2 ordered pairs. So let's go ahead and take a look. Now, when you're probably taught this in Algebra 1 or in pre-algebra, they always teach you first by graphing them. So you would be given 2 equations of the line, you'd put them in slope-intercept, you'd graph the 2 lines, and you'd find the point where the 2 lines cross. Then the next lesson generally in your chapter would be the substitution method. And then finally, the third method is the elimination method. So they always start out with the longer one first, and then they work up to the easier method. Now, for some of these nonlinears, you may have to you won't be able to choose. You're either going to have to do a substitution or elimination. We're not going to be graphing them. When you do the web assign, I believe they're going to give you a picture, so that could be a clue of how many solutions you're looking for. But for the method of substitution, what we're going to do is solve either equation you can choose for one of the variables. The variable that I'm going to solve for, I'm going to try to choose one that does not have a number in front, so where it's got a coefficient of 1. Then once I rearrange that, and for example, maybe put it into y equals mx plus b form, once I get the expression for that variable, then I'm going to plug it back in to the other equation. And then from there, I'll solve for the variable, get that variable's value, and then plug it back in to get the remaining variable. So when we're done solving our systems, our answers are going to be ordered pairs. So let's go ahead and take a look at our first example. These are two linear equations. I'm going to show you how to solve this one both using the substitution method and using the elimination method. I'm going to do substitution first. So step number 1 is to pick one of your equations and solve it for either x or y. So I'm going to go ahead and take my first equation, x plus y equals 4, and I'm going to solve it for y. So I'm going to subtract x, and I get y equals 4 minus x. You could put negative x plus 4, that's fine as well. Now that I've rearranged my first equation, I'm going to take the expression, what I just solved for y, and I'm going to substitute that into my second equation where I see the variable y. So I take x, and I'm going to rewrite the equation here. I'll do it in black, minus y equals 2. Again, I'm going to take out only the letter y, and I'm going to put in 4 minus x. And I'm going to put it in parentheses because notice it's got a subtraction sign in front here. I need to remember to distribute that subtraction sign. So then this will become x minus 4 plus x equals 2. I can combine my like terms. 1x plus 1x is 2x. I'll drop down the minus 4 equals 2. I'm going to add the 4. 2x equals 6. Divide by 2. And x equals 3. Now, remember, the solution to this system is an ordered pair. Now what I need to do is take what I just found x equals, and I'm going to plug it back in to one of the original equations. I could also, if I'm confident in my rearranging technique here, I could also plug it in there. I'll go ahead and plug it into the first one. So x plus y equals 4. I'm now going to take out x and put in what I just found x equals. So 3 plus y equals 4. And now I solve for y by subtracting 3, and y equals 1. So the solution to this system is going to be the ordered pair 3, 1. Now, it's very important that you're nice and neat because sometimes you may not solve for x first. Maybe you'll solve for y first. So it's important that you're labeling what you're solving for. You know, don't be real messy because it can mess up your ordered pairs. Now, one thing, if you ever have time to check your work, what you can do is to just confirm that this ordered pair does work. You would have to plug it in to both of the originals. So x plus y equals 4, x minus y equals 2. Remember, this is x, this is y. So if I do 3 plus 1, if it doesn't equal 4, I've made a mistake. And then I need to do it in the second one. It's got to work for both. If it didn't, then I did something wrong. So this is a way to double check your answer really quick by plugging in the ordered pair for x and y. It saves your answer a lot of times because the problem is one bad sign mistake and the whole thing's messed up. Like let's say you forgot to distribute up here when you had the subtraction sign, you could have messed up your answer. So if there's time, just quick plug it in. And then that's a way to double check it. Now, I'm going to do the exact same problem and I'm going to do elimination. Now, in this particular problem, the way it was given, it's really better to solve it with elimination when it's already set nice and pretty for you. And what I mean by that is my two equations were x plus y equals 4, x minus y equals 2. When I do the elimination method, I'm going to be adding the two equations together. If your equations are already set, with one of the variables, either x's or the y's, to have the same number but one positive, one negative, when I go to add straight up and down, notice my y's are going to cancel. So here I'm going to add straight up and down. 1x plus 1x is 2x. But then when I go to do the y's, 1y plus negative 1y, that's gone. And then you're left with 4 plus 2. And now you just divide, and x equals 3. And then you plug it back in to get the y. Yes?
So for the first step that you did, how did you know to find y instead of x? Or does that matter?
In the other method, the substitution?
Yeah.
It didn't matter. Okay, so you could have also solved that for x. You can choose. What I always do is look for the variable that doesn't have a number in front, and in this case, both the x and the y didn't have a number. So yes, you could have solved and rearranged it for x. It doesn't matter. And that's why, okay. That's why I really always stress to be nice and neat, because normally you might think, oh, I'm always solving for x first. That may not be the case. Everybody good so far? All right, let's try number 2. I'm going to do substitution on this one. Again, now, sometimes if you wanted to do elimination, sometimes you're going to have to multiply one of the equations by a number to get it to eliminate. And I'm actually going to show you that when I do example 4. So for this one, I'm going to do substitution again. I'm going to solve my first equation for x. So x minus y equals 0. I'm going to add y, and I get x equals y. So this should be a clue that when we're all done, the ordered pair we get is going to have the same number for both x and y. But let's go ahead and follow through and do the substitution. So the equation that you rearrange, you cannot plug what you just got back into it. You have to plug it into the second one, or the other one. So here, I'm going to take out x, and I'm going to replace it with what x equals, which is y. So now I get 5y minus 3y equals 6. Add my like terms. Divide by 2. And this time I solved for y first, and y equals 3. Now to get what x equals, again, I can plug it back in to any one of these 3. So obviously x is going to be 3, but just to show you, let's say I plugged it into the first one. If I plug in y equals 3, solve for x by adding 3, x equals 3. So 3 comma 3 is my answer. And I already knew they were going to be the same number because of how I rearranged that one. Pretty good so far? Coming back to you, you probably should have done this in your Algebra 1 course. Let's try a word problem. This would be something you might see on an SAT, where they give you a word problem. Maybe the question might just say, give me the 2 equations that you would set up to solve the system. They may not ask you to solve it. Or again, they may give you the system with the word problem and then ask you to solve it. So we're going to go ahead and define our variables. I'm going to use x and y. I am going to let x in this problem be the amount that's invested at 5%. And then I'm going to let y be the amount that's invested at 3%. Now, when I go to set up my system, I'm going to have an equation for the amount of money that's being invested, and then I'm going to have my second equation for the interest amount. So I know that some amount was invested at 5%, and then whatever out of the 12,000 that wasn't invested at 5%, the remaining went at 3%. So I could say x plus y equals 12,000. The next equation is going to take into consideration the percent of interest. Now, whenever you work and figure out simple interest, you need to change the percent to a decimal. And the way that I change a percent to a decimal is dividing by 100 or just moving the decimal point 2 times to the left. So 5% as a decimal would be 0.05x. 3%, 0.03y. And the amount of interest was $500. I now need to solve for both x and y. The amount I get for my variable x is the amount of money out of the 12,000 that was invested at 5%. And then once I solve for y, it'll be the amount that I invested at 3%. Now, I don't like to deal with decimals, so I'm going to get rid of those decimal points by multiplying that second equation by 100. Now, if you like decimals, you could leave it there. That is fine. But what I'm going to do, essentially, I'm just moving my decimal point 2 times on all of them, including the 500. And the math behind it is multiplying it by 100. So then this new equation is going to become 5x plus 3y equals 50,000. Now, I'm going to solve number 3 using substitution. I'm going to solve number 4, which is the exact same type of problem. The only difference is the numbers have changed. And I'm going to solve number 4 using elimination. Again, you can choose either method here. It doesn't matter. So I'm going to go ahead and I am going to solve my first equation. Again, I look for the variable that doesn't have a number in front. So I can choose to solve x plus y equals 12,000 for either x or y. I'm going to go ahead and solve it for x. So I'm going to go ahead over here to the side. So I'm going to take x plus y equals 12,000. And because I'm doing substitution, I'm going to solve it for x. You could do it for y as well. But I'm going to move the y to the other side and get x equals 12,000 minus y. This is what I'm going to substitute for x in this equation, the second one. So I'm going to take out this x, and I'm going to put 12 minus y in its place. I have to distribute the 5 that's in front. So let's go ahead and fill all this in. So I have 5. Oops, sorry. Let me try to do this in color here. I'm going to do 5. And then parentheses, I'm going to put 12,000 minus y. Rewrite the rest of the problem. I'm now going to distribute the 5, and this gives me 60,000 minus 5y plus 3y equals 50,000. I can combine my like terms. So I can combine negative 5 plus 3 and get negative 2y. Let me rewrite everything else. And now I'll move the 60,000 over to isolate the y. And I get negative 2y is equal to negative 10,000. Divide by negative 2. And y equals 5,000. So $5,000 was invested at 3%. To get the amount at 5%, remember you take it and you plug it back into one of the beginning ones. I'm going to use the very first one. X plus y equals 12,000. Plug in Take out the y, put 5,000 in its place. So x plus 5,000 equals 12,000. Solve for x by subtracting 5,000. And x equals 7,000. So if they ask you to list it as an ordered pair, again, x goes first, y goes second. If they ask you to describe it in words, then you would say $7,000 was invested at 5%, and $3,000 or $5,000 was invested at 3%.
So on the test,
I don't know what we're doing on the test yet. More than likely, you'll be listing them as ordered pairs. But just be aware of this for an SAT. More than likely, they may ask you to describe it into words. All right, now I'm going to do the exact same type of problem, but now instead of substitution, I'm going to use elimination. Again, just be aware of the different techniques because, again, they may just ask you on an SAT to set up the equations, maybe not necessarily solve. So let's try the next one. For the next one, same thing, but this time, instead of 12,000 investment, it's 25,000. And the interest rate is 6.5 and 8.5. And then by time they're done, the annual interest would be 2,000. So let's go ahead and set it up. Again, the same thing. X will be, for this one, X is going to be the money that's invested at 8.5. And Y will be the money invested at 6.5. So X plus Y, this time the amount of money invested is 25,000. And again, we're going to turn those percentages into decimals. So 0.065X plus 0.085Y equals, and this time the interest is 2,000. Again, I'm going to get rid of those decimal points. If you prefer to work with decimals, you can leave them. But it makes it a lot easier when you're not having to deal with decimals, especially if it's a non-calculator test. So here, this time instead of moving it twice, I need to move it 1, 2, 3 times, so it becomes 65x. If I move it 3 times there, I got to move it 3 times here, as same over here. So we'd add 3 zeros. So this is essentially multiplying it by 1,000. Now, and I'm going to be, so then it becomes 85y. And 1, 2, 3, 2 million. So now, my two equations that I have, x plus y equals 25,000, and 65x plus 85y equals 2 million. Now, I told you I would show you how to do elimination here. So when you do the elimination method, you have to decide which variable you want to eliminate. And the way that you do that is you make the numbers in front of that variable that you're going to eliminate to be the same, but one's positive and one's negative. I'm going to eliminate x. So to do that, I'm going to multiply my first equation by negative 65. I'm going to distribute that negative 65 to all 3 pieces. So once I distribute it, it now becomes negative 65x, negative 65y, and then 25,000 times, 1, 2, 3, times negative 65 gives me negative 1,625,000. Yes.
If we want to, we could also use substitution.
Correct. So I just wanted to be able to demonstrate, because the substitution would have been the same that I did for number 3. So I just want to show you that you have options here that you can choose. This one, the numbers are getting kind of big. So maybe elimination might not have been the best option here if you weren't using a calculator. So here, once I go now to add the two equations together, x's are gone. 85y plus negative 65y is 20y. And then 2 million minus 1,625,000 gives me 375,000. Going to divide that by 20. And the y becomes 18,750. So of that $25,000 invested, 18,750 was invested at the higher interest rate, the 8.5. Now I need to find out how much was invested at 6.5. So again, take your original, and again, it doesn't matter which. Plug in what you just found for y, and then solve for x. So x plus 18,750 equals 25,000. Subtract. And x is equal to 6,250. So as in ordered pair, 6,250, 18,750. And again, if you had to describe it in words, $6,250 was invested at 6.5%, and 18,750 was invested at the higher rate of 8.5%. And yes.
How do you know which variable goes into which percentage?
Whatever you decide to define at the beginning, you can decide. So if you would have preferred to have x set up with the 8.5, then just make sure that you're defining that somewhere so you know. Okay, you can choose. It doesn't matter. I just did it as I read it, and the first amount I came to, I put with x, and then the second with y. But again, it doesn't matter. So these are all examples of linear systems. We got one solution for all of them. Now we're going to do some examples of nonlinear systems. And again, remember the nonlinear: parabolas, hyperbolas, ellipses, circles. Those are all nonlinear. They've got a curve to them. Pretty good? Let's try examples 5 and 6. So again, nonlinear. The way that you can tell that it's going to be nonlinear is the equation is going to have exponents in it. If none of the variables have exponents, that's a clue that it's linear. So exponents make it nonlinear. And again, as I showed you at the beginning, you can have more than one solution. So let's take a look at our first example. Now for this one, it's too difficult probably to do an elimination here. So because we've got too many variables going on. So we're going to do a substitution. So I'm going to take the linear equation, the second one, and I'm going to solve it for y. Notice the y, once I'm done, is not going to have a number in front, and then I don't have any fractions to deal with. So I'm going to go ahead and subtract the 2x, and I get negative y equals negative 2x minus 1. I'm going to divide everything by negative 1. And I get y equals 2x plus 1. Y equals mx plus b form here. Now what I'm going to do is I'm going to take the rearranged version of the second equation, this expression, and I'm going to substitute it in for this y of the first equation. So let me go ahead and rewrite the first equation. 3x plus 4x, 3x squared plus 4x minus y equals 7. So again, I'm going to take out only the y. I'm going to leave everything else there. So I'm going to leave the 3x squared, the 4x. I'm leaving the subtraction sign. I'm taking out only the y, and I'm going to put this in parentheses because, again, we need to remember to distribute the subtraction sign. So once I distribute it, I end up getting this, negative 2x minus 1 equals 7. I now need to combine like terms. 3x squared. I can add these two together. This becomes a 2x. And then I need to move the 7. When they're nonlinear, we're going to need to factor. Now, if your equation can't be factored, then you're going to use quadratic formula. This one I can factor. Now, you can use whatever technique for factoring that you choose. So if you want to do guess and test, factor by grouping, whatever it is, you can choose. I'm going to go ahead and do guess and test because my numbers are small enough. So my factors of 3x squared are going to be 3x times 1x. And then my factors of 8 are going to be either 1 and 8 or 4 and 2. And it's actually going to be negative 4, positive 2. And if you're going to do the guess and test technique, you need to do a quick FOIL on this and make sure it goes back. Now, if you're not good at guessing and testing, then do factor by grouping or whatever technique you want to use. So these are my factors. It does FOIL back. These are good. So now what I'm going to do is set each factor equal to 0. So 3x minus 4 equals 0. And x plus 2 equals 0. I'm going to solve each one for x. I'm going to add 4. 3x equals 4. Divide by 3. And x equals 4/3 on that one. Over here, subtract 2. X equals negative 2. Now remember, our solutions are order pairs. I'm not just looking for x. So now remember, we need to take both of these x values and plug them back in to the original. You can choose. Again, I'm going to choose the linear. So I'm going to, again, you can either choose this one, or this one. Just to stay consistent, I'll plug it into the second one here. Even though the rearranged looks easier. 2x minus 1 equals negative 1. I'm going to write it twice because I have two x values. Because again, remember, these two equations can touch in two places. So that's why I'm getting two ordered pairs here. So I'm taking what x equals, plugging it in, and solving for y. So 2 times 4/3 minus y equals negative 1. Going to multiply here. I get 8/3 minus y equals negative 1. I need to subtract the 8/3. I'm going to change the whole number 1. I'm going to make this negative 1. I'm going to make it negative 3/3. So it has a common denominator. So now I have negative y equals negative 11/3. Can't have a negative y, so I divide both sides by negative 1. And y equals 11/3. So my first order pair is 4/3. That's the x value. And then the y value is 11/3. Need to do the same thing for the x equals negative 2. Plug it in. multiply, move the -4 over, negative y equals 3, and then now I will divide both sides by -1, y equals -3, so the order pair to the system, the solution to the system, is also -2, -3. So these are your two solutions to this system. Again, the two graphs touch at both of these order pairs. Let's try one more example. Again, a nonlinear system with a linear system. I'm going to rearrange the linear and do a substitution. So I'm going to take 2x minus y equals -3. I'm going to solve it for y. And the reason why I'm choosing y is because once I'm done, there's no coefficient in front of that. And I don't end up with any fractions. So then I end up with -y equals -2x minus 3. Divide everything by -1. And y equals 2x plus 3. Yes?
Why did you change the 2x to positive?
2x to positive. Where? From this step to this step?
Oh wait, no, never mind. On number 6 for me, it's a -2x. Sorry.
You know what? You know what I did? Ugh. I jumped. I'm sorry. I'm doing the wrong problem. I am starting to do number 8. Let me come back up here. Thank you. All right, so number 6, I'm still rearranging the linear. -2x plus y equals 5. I'm going to add the 2x. Y equals 2x plus 5. I'm going to substitute 2x plus 5 in for the y in the second equation. So let's go ahead and write it out. X squared minus, and then in the parentheses I'll put the y value, because again I'm distributing a subtraction sign. If that were an addition sign, you don't worry about it, it's just the numbers would stay the same. But in this case, once we distribute that subtraction, both of the numbers, their sign switches. And now I can combine my like terms. I've got a -2 and a +3 that I can combine together. And I get x squared plus x minus 5 equals 1. Move the 1. X squared plus x minus 6 equals 0. I now have a trinomial that I can factor. Factors of -6 that give me +1 are going to be +3 and -2. And again, do a quick FOIL, double check that it does give you the middle term, and it does work out. Take each of the factors, set them equal to 0. Subtract 3. X equals -3. Add 2. X equals +2. Again, we're looking for ordered pairs. So now let me come on over here. So again, I'm going to go back to my original, and I'm going to plug in both of these x values. So my original, -2x plus y equals 5. And then I'll write it again, -2x plus y equals 5. Because I have to plug in both -3 and +2. And solve for y on both. So the first one becomes -2 times -3 is +6. Move the 6. y equals -1. So my first order pair is -3, -1. And the second order pair, multiply, add the 4, y equals 9. So the second order pair, I plugged in a 2, and I got 9 for the answer. So the solution to this system are the order pairs -3, -1, and +2, +9. Again, remember, you can always take your two solutions and plug them in. Both have to work in order, like -3, -1, when you plug it into both equations, it's got to work for both. Then if you try the 2, 9, anytime it doesn't equal, you've done something wrong somewhere, and I would go back and start all over again. So I accidentally started number 8, but I will redo it tomorrow. So the rest of the notes, as you saw when I messed up and did number 8, the process is still the same. We're going to try to do a substitution. If the substitution doesn't work out, if you could look at it and say, wait a minute, I think elimination might be better, you can do that as well. But most of the time for the nonlinear, substitution would be better. All right, so the web assign's not due tomorrow, it's due Thursday, but you've learned enough where you can start it if you wish. Have a great afternoon.